Hey, Algebra 1. So today we're looking at graphing absolute value functions, and our learning target is that you'll be able to graph an absolute value function. So we graph these on an XY graph, coordinate plane, not number lines. Okay, what if we have like a super complicated problem? It's got some of everything, every single possible transformation, all in one problem. So inside the lines, I've got that +5. That is going to move my vertex left 5 spaces. Outside the absolute value, I've got that blue +1. That is going to move my vertex up 1 space. And in the front of the absolute value, that -2 that is highlighted in yellow, that is going to do two things. There's like for the description, there are two different parts to the description. I'm going to do it onto the graph all as one thing. The negative sign turns my V shape upside down, so it's gonna have the vertex at the top, and then the V shape is pointing down. Also, it's gonna make the slope 2. Or we could just think of it as saying, hey, you know what? The slope is going to be -2 on the right hand side. So let's find the location of the vertex first. So starting at the middle of the graph, we're going to go left 5 spaces and up 1 space. Here is the vertex point. And then from there, I'm going to do a slope of -2. So I'm going to scroll down a little bit so you can actually have enough room to draw the graph. So from that vertex, down to right 1, down to right 1. And then that is one side of the V, return to the vertex, and this time we'll go down 2 spaces and left 1, down 2 spaces and left 1. So there's my V-shape graph. Scroll up so we can see the equation again. So my vertex shifted left 5 spaces and up 1 space. Once I got the vertex positioned, then I can use the yellow slope to get an upside down V shape that is stretched twice as tall with a slope of 2. All right, let's look at this next example. So y equals -3/2, absolute value of x minus 4 plus 2. So let's just go in order from left to right and look at what the different transformations are. So -3/2, that's like the slope. Really, it's the slope of the right arm of that V shape. But I can see because of the negative sign, this V shape is going to be going down with the vertex will be up and the arms will be pointing down. Inside the absolute value, I've got a -4. And so I know that is going to take that vertex and slide it sideways. Everything inside always goes sideways. And the inside transformations always are opposite. So it says minus, but it's actually going to be moving towards the right. And then lastly, this +2 that's outside the lines is going to move vertically. I'll move that vertex, in this case, up since it is positive. The outside the lines transformations, we can just read them at face value. If it says plus, it's actually doing plus. This is like the slope, and I know that it will be this kind of a shape because of the negative sign, the rise and run. 3 is the rise, 2 is the run. The green one is going to go to the right 4 spaces. And that blue one is going to move the vertex up 2 spaces. All right, so let's go. So I'm going to find the vertex first. So even though the slope shows up in the equation first, I'm not ready to use that. I need a starting point. I need the vertex before I can actually do anything with the slope. So I'm going to go on the graph. I'm going to go right 4 spaces and up 2 spaces. That will tell me where my vertex is at. 1, 2, 3, 4, and 1, 2. Here is my vertex. Okay, and I'm not ever going to count right 4 and over 2, or right 4 and up 2 again. That's not the slope. That's just how I located the vertex. From the vertex, now I'm going to use this magenta slope of -3/2. So let's do the right-hand side of my V-shaped graph first. So from the vertex, I'm going to go down 3 because of -1, 2, 3, and right 2. And there's my next point. If I had more space on the graph, I could get another point drawn. I could probably get this to fit. I got enough space, even though the graph ends. So down 1, 2, 3, right 1, 2. I mean, it's off the edge of the graph, but it'd be like right here. Okay, return to the vertex, and let's do the left-hand side of that V shape. So again, the rise and the run, still down 3 and over 2, but this time I'll have to go the other direction for over. So it'll be left 1, 2, 3, and left 2. 1, 2, 3, and left 2. And then blam. Okay, so my vertex moved to the right 4 spaces and up 2 spaces, counting from the center point in the graph at 0, 0. And then because of this magenta slope being negative, the V does not go like this. Instead, it goes with the vertex at the top and the arrows pointing down. The rise was 3 and the run is 2. There's my graph. Last example, I've got y equals 2 absolute value of x plus 3 plus 1. All right, so my slope is like that's like the slope. That's 2, so it's gonna really, it describes the slope of the right-hand side of the V. Inside the lines, I've got that plus 3, so that is going to move the vertex side to side. And I remember that plus is going to move it to the left. And then outside the lines, I've got this plus 1 in blue, and so that is going to move the vertex up 1. So I remember all of those transformations that are outside of the lines, we just read them at face value. If it says plus, it goes plus. But the inside, that green one, is going to be opposite. So it says plus 3, but really it's like -3 on the graph. Okay. One final thought here. Never, 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 never combine transformations. So I've got the magenta, the green, the blue. Those are 3 separate transformations. We do not ever combine them. Do not distribute. Do not combine like terms. We cannot do that. It doesn't work. So let's label. So that is my slope, and the shape of the graph is going to look just like a V because that slope is a positive. The green transformation, that's going to go left. Oops, left 3 spaces. The vertex will move to the left by 3 spaces, and the blue one, that is going to move the vertex up 1 space. Okay, so first thing I want to do is locate the vertex. So I'm going to go left 3 spaces and up 1. Here is my vertex point. And then from the vertex, I'm going to use that magenta slope from the equation to find my next point. So the slope is 2. It's positive 2. I'm going to do the right-hand side first. That will actually have the slope of 2. So from the vertex, up 2 spaces and right 1. Up 2 spaces and right 1. Okay, so if we want to see that in numbers in the original equation, I'm going to give the rise was 2, but I'm going to insert that run of 1, which was invisible, just so we can see it in the equation written down. Okay, now I still need to draw the other side of the V shape. So return to the vertex. It'll have the same slope of 2, or same rise and run of 2 and 1, but this time the run is going to go the other direction to get the other side of the V. So from the vertex, up 2 spaces and left 1, and then again up 2 spaces and left 1. This is going to go right on top of that equation. Ugh. All right, and then probably should move the equation out of the way. So that is what this graph looks like. The vertex slid to the left 3 spaces. It slid up 1 space. So that's my vertex. Never, never, never count the 3 spaces and 1 again. That's not how we find the slope. The slope is that magenta number, which was 2 over 1. All right, there's that graph.